Alright, the next set of questions we're going to talk about are questions 39, 19, 37, and 38. These are all kind of tied together because they all have to do with properties of logarithms. And actually, this is also, I consider, a property of logarithm. It's when you learn about it in the same section in a math book, typically, is switching from exponential form to logarithmic form. So hopefully you've seen these rules before, and I'm actually going to need all my whiteboard space, so access these really quick or write them down. They're going to look different depending on where you look them up if you Google them, but if you Google properties of logarithms, they should give you these three. And again, exponential form into logarithmic form. And the reason we get to do this is because where logarithms come from is typically it's the inverse, it's the undoing of exponentiating. That's why we get to write them as either one of these forms. It's the same as writing a multiplication as a division problem. I can say 3 times 1/2 is the same as 3 divided by 2. I can change those forms because they're inverse operations of each other. Logarithms are the inverse of exponentiating. So again, hopefully you've seen these rules before. I'm going to refer back to these three, and this is the form change that I'll refer back to. So either write those down or have access to them from a textbook or Google or something like that. I'm going to need more space here. So this one thing to point out that's important to remember, and you'll need this for calculus, is with logarithms, addition is related to multiplication, subtraction is related to division, and then this is kind of the power rule. I'll call that the power rule because this has a direct correlation to a calculus concept we'll learn in a little bit. So I'm going to start with question number 39 because it actually outlines this exponential form into logarithmic form. So question number 39 looks like this. Logarithm base 8 of 1 equals 0. And your directions are change into exponential form. So we basically have something that's written in logarithmic form like this, and we're going to change it to the other form, exponential form. Again, it's like inverse operations. So I can write a division problem as a multiplication problem. So until you get really used to converting these, and you will, it's paint by numbers. Make this paint by numbers. Your base, B, I mean paint by numbers, math by numbers by assigning, just labeling these. 8 is our base, that's B, Y is 1, and X is 0. I'm just looking where these things are in that equation and labeling them. So when I rewrite, it turns into this. That B to the power of X, so 8 to the power of 0, 8 to the power of 0 equals whatever Y is. This is all it is. We've changed this logarithmic equation into that exponential equation. And this is like a true statement in math. 8 to the 0th power is equal to 1. Anything to the 0th power is equal to 1. So we're done. We're not asked to do anything, evaluate, or anything like that. We're just looking to get it in this form. So one thing to remember is we're just changing these two forms. Again, it's kind of like multiplication and division. These are inverse operations. I can write it in this form or I can leave it in this form, depending on what the problems are going to ask of us. So that's question number 39, kind of the most straightforward and directly just using that form change. And again, if you don't have that committed to memory, typically students don't, but then when we start working with them, they do memorize it. So question number 19. Log base 6 of 9 minus log base 6 of the quantity 4 times x equals 3. Now I don't think the worksheet had a parentheses around that, so that may have been a little misleading, but kind of with that base of 6, whatever follows is implied that's what you're doing the operation on. So referring back to those rules, first of all, you can only use those rules if these bases are the same number. If these are different bases, then we've got other problems, but we're going to keep this pretty nice and easy for you, so you'll typically see the same base. So I see I've got log base 6 of something minus log base 6 of something else. So one thing I can do is use that rule, like the second rule down, subtraction, and relate these two things with division. I can do log base 6, because that's the same base, of this divided by that. I'm going to take this subtraction and make it a division of those two quantities. So 9 divided by negative 4x. Write that in a big parentheses here. So that's what I've done on the left-hand side. Equals 3 is still on the right-hand side. And I'm going to change markers because the black looks like it's running out. So we get this expression. All right, so we've done some progress. We've made 2 logarithms into a single logarithm. And sometimes the directions state that right as a single logarithm, and we would be done in that case, but we're actually solving this thing for x. So now what I have is something that's in logarithmic form. Log base 6 of some quantity equals some other quantity. I'm looking at something that looks like that. Log base b of y equals x. So again, I'm going to make this math by numbers. I'm going to write b for this. I'm going to write y for that. And I'm going to write x for this. So after you get to kind of get used to this, what I think of is this base to that power equals this. That's kind of the pattern. This base to that power equals that. So let's write that down. That base to that power equals that thing. Okay? And just to make sure that everything lined up, b and x. So b is our base, x is that power, and y is on the other side. So there you go. This is a linear equation. 6 to the third, I can evaluate that. X is in the denominator. I'm just trying to get this thing solved for x. I'm going to move it over here. 6 to the third power from our previous video. So 216 equals 9 over negative 4x. So hopefully at this point you kind of know what to do, and that's the idea of the properties of logarithms. So to finish this off, I'm going to multiply both sides by negative 4x to get it out of that denominator. So we got negative 4x times 216 was there, and I'm going to divide by 216, so 9 over 216, and then divide by negative 4. X equals 9 over 216 times that negative 4. Now, I've kind of got a really hairy-looking expression here, and I think on this question, I don't know if the directions, let me look real quick, if they said keep exact, 19, solve each log equation, but the thing is, if you use your calculator and got a decimal, and I think the decimal is, looking back here, I guess I don't have it written down. The exact answer, if you simplify this by hand, you reduce that fraction to negative 1 over 96. Now that's going to be the answer that was on the worksheet. However, if you have its decimal form and you check to see if you have the correct decimal form, I'm alright with that too. I'm pretty lenient on stuff like that. Now if the directions said keep an exact, that would be the correct answer. A decimal would be incorrect. I mean, if like you had to round it or something like that. So we'll talk more about that during the year. So that was question number 19, and hopefully the properties of logarithms is what you were confused on if you got that one wrong.